The theme which I'd like to take tonight is simply the scientific consciousness, specifically the modern scientific consciousness. But I want to do this orientated in the context of Goethe. I shall not be talking much about Goethe at all, because as you know, Goethe developed a different kind of science, and one which brought him into controversy with the mainstream science of his day, Newtonian physics, and a science which was rejected for quite a long time by a lot of people as being the work of a scientific dilettante. But gradually, over time, people have become interested in it and have gone into it and have seen that there was rather more to it than they thought at first. And that today, for various reasons, from quite a number of different directions, there's quite a growing interest in Goethe's way of science as an alternative kind of science. Now, this idea that there is another kind of science is one which gives a lot of us some difficulty. We can't see how there can be another kind of science because we believe that science is based on the direct experience of the world through the senses, augmented by means of experiments. It's often said in books and taught in schools that modern science began when people came to their senses and started investigating the world in this way rather than speculating or whatever it was that they imagined they had done before. This is called the empirical approach to science. And obviously, if you have that kind of understanding of what science is, then it would be very difficult to see how there could be another kind of science. You think, well, there can't be two kinds of sciences, because surely there can only be one, and that must be the one that's right, and we can find out which one is right by investigating the world through the senses and through observation and through experiment and so on. So there isn't a problem. If we've got two sciences, we can soon find out which one is right by appeal to direct experience. In any case, we probably wouldn't bother because we're so convinced that our mainstream science is the correct one. Why take the trouble? Well, with this assurance then, it's quite easy for people to either reject Goethe's idea or for people coming to it to be very puzzled about how there can be two sciences, two kinds of science. How could they both be right? Surely only one of them could be. Well, this judgment that we make turns upon a supposition, or rather a prejudgment, and that is that modern science is empirical. That is, that modern science is based on observation, the experience of the senses, augmented by experiment. This is the assumption that is actually made here. That is, that we can gain knowledge of the world directly from sense experience. And we've all been brought up to believe this, and it turns out that it just isn't true. And over the last 30 years or so, this idea that science is certain because it's based on the certain experience of the senses has in fact been shown to be unfounded. And studies in the philosophy of science and the history of modern science have shown that it is not empirical in the way in which we imagine it to be. And one of the things I want to talk about tonight, in a moment, the first thing will be what would come from what I will call, what is often called, the new philosophy of science. Well, there's a bit of a vogue on for new things, isn't there? There's always the new, this, that and the other. And the fundamental proposition here is that, I don't know if you can read my writing, but never mind, scientific knowledge is not empirical. I'll put in brackets, so not to upset people too much at this stage, in the way that we think. This idea has gradually gained in credence since the early 1960s. The seminal event here would be the publication of Thomas Kuhn's book, The Structure of Scientific Revolutions, which more people have talked about than have read. It is an absolutely brilliant book. I have read it twice. I read it when it first came out, because at that time I was in, as Brian mentioned, a research student with David Bohm. David Bohm knew about it immediately, and we had a whole term seminar on Thomas Kuhn's Structure of Scientific Revolutions as seen through the eyes of David Bohm. It was an incredible experience. The writing of Kuhn's book is fantastic. He's a brilliant writer. Not many people can write prose as well as he does. It's a joy just to read for the quality of the writing, if for nothing else. Well, that is a kind of turning point here, but there were many other people involved. Stephen Toulmin in this country, who then moved to America. Paul Feyerabend, who's of course well known. And as always happens when there's a big revolution in understanding, afterwards people see there were all sorts of precursors. People were saying this before, but nobody noticed, so I won't go into it, but it's quite amazing now when one looks back. It's very interesting, for example, the French didn't take any notice of Kuhn. Well, there may be many reasons for that, but one reason is that they had their own philosopher, Gaston Bachelard and Georges Canguilhem, who had actually been saying what Kuhn said for some years, so it didn't come as any surprise to them. In Germany, surprisingly enough, in the middle of the 1930s, Heidegger had been saying this, and Edmund Husserl in his last book, The Crisis of the European Sciences and Transcendental Phenomenology. Alexander Koyré came from Hungary to Paris and said the same things in manuscripts there, which he wrote and then lost when the Nazis took over, and rewrote again after the war when he went to America. And most astonishingly of all to me, a lecturer at Columbia University in New York, E.A. Burt, who wrote a book called The Metaphysical Foundations of Modern Science, which is actually based on lectures given in the 1920s. And every time I look at that book, I just can't believe it, because it is so prescient. But it goes back even further. As if we wanted to go the whole way back, then we can go back to Plato. The Dialogue Theaetetus gives what's probably the best illustration that is that scientific knowledge, or knowledge of the world in general, is not in fact empirical. It cannot be based directly on sense experience. So we seem, in one way there's nothing new about this, in another way it's astonishingly new to us particularly, who've been brought up to believe that that's exactly what science is. So this will therefore be partly an introduction to some aspects of what's now called the post-empirical or post-empiricist philosophy of science, also of course inevitably now the postmodern philosophy of science, because everything is now postmodern. The second phase of this, where it was seen that scientific knowledge was not what we thought, came with what is, since the little bit after this, since the 1970s, what's now called, of course, the new history of science. And this is something which I shall be talking about, and is very interesting because here the discovery has been made that scientific knowledge is intrinsically historical. And that is, I'll say what that means in a minute, and the examples I will give later will hopefully show it. Intrinsically historical. Now, obviously, what that means is the opposite of extrinsically historical. So I can't think while I'm writing on that board, so I have to fill in with something obvious enough for my mind, you know. If something is extrinsically historical, also, because scientific knowledge is historical, everything human beings do is historical in the sense that it takes place in historical time. So you can date Galileo around about 1600 and Newton around about 1660 and so on. So in that sense, science is clearly historical. It developed historically. That's not what is meant. What is meant here is that when we actually look carefully at the development of science, we see that there is a dimension of science, a historical dimension within science itself. We usually think of science as within history. We don't think of history as within science. You've got to turn it inside out. That within scientific knowledge, there is a historical dimension in the sense that cultural historical factors, which come from the cultural historical context in which science is done, those factors enter into the very form which scientific knowledge takes. And therefore science cannot be decontextualized. It cannot be divorced into some activity of a pure, acultural, ahistorical, atemporal, alinguistic, apolitical, asocial, scientific consciousness, which is, of course, how people like to present it. There's something called the scientific consciousness, the scientific method. When the scientist does his work, he removes himself from all possible influences into some pure realm. Therefore, science can be treated independently of all other human activities. The great discovery has been that it cannot be. It's not just that science influences culture, it is that culture influences society and science in very fundamental ways. And I'll try to look at a couple of examples of this that I may have to, depends, I may have to drop it to one. I should certainly look at Copernicus and the Temple of the Sun, and I'd like to look briefly, if I can, at what Darwin was really doing. Because it's very illuminating when one approaches it from this point of view, but I simply may not have time. We shall see how we go. So, this is often referred to as the discovery of the historicity of scientific knowledge. That word historicity tends to get used, you may not be familiar with it. It's widely used in its equivalent in Germany and in German philosophy and on the continent, and now in America. But it's not a word that's used very much here. But if you catch me talking about the historicity of scientific knowledge, what I'm talking about is the way in which there is a historical dimension within scientific knowledge itself, which will become clearer, hopefully, as we go on. So I want to try to illustrate both these things tonight, if I can. It's really all a question of time. The problem with this kind of thing is you can't go too quickly because people can't handle it. It's just not right. You've got to sort of go at a certain pace because otherwise people can't grasp what you're talking about. This isn't an academic lecture where you stand up and sort of gabble it off and get it done and off you go. And nobody's interested in that. So one can't go too quickly, and it's quite difficult to get it all in, therefore. But I want to begin with the first part, with the scientific knowledge is not, in fact, empirical in the way in which we think. And really, I can approach this, there's a number of ways one can approach it, but I think I can approach it fairly directly in terms of simply cognitive psychology. It's very difficult. What we need to do is, as it were, to understand something about what knowledge is. What is knowing the world? This is a philosophical question. Not what you know about the world, but what is the act of knowing the world? And it's very hard to get at this because, in a certain sense, it's all over in the blink of an eye. I mean, at the present moment, we're here, we know an awful lot of things. I mean, simply I know that I'm standing in front of here, this is a table, there's a jug of water there. All this is sort of there for me, but it's all known already. And so it's quite difficult to see what's actually going on. Now, one way of getting at this is to look for a situation where there's a breakdown, where the normal process of cognitive perception is in some way disrupted. Because then what is normally hidden in the smooth working of the process is revealed, made visible. And we can do this partly like this. Now, what I've got here is a picture. Good Lord, I can't see a thing. That's not the idea at all. Now, I know what to do. I've got it worked out now. That's it. There we are. That's it. Now, I think that's focused, and the focusing will be here, I presume. It's all right, I'm a physicist. I'm utterly hopeless with any kind of machine. I usually knock them over or they break before I even get to them. I'm surprised the bulb hasn't blown already, actually. Wouldn't be the first time. There we have a kind of figure which consists of a lot of, well, people usually see random jumble of chaotic black shapes. You might, of course, see white shapes and so on. And first of all, that's what you see. That's your direct experience. But if, in fact, and this will happen to some of you already, if someone tells you that there is a giraffe there, oh yeah, it's not too difficult to see it. There is the head and neck of a giraffe. The horny bits are there. And there's the I can't get this one. There's the neck, yes. And then this part over here is the is the nose. Can you all see it? Mm. It's not difficult, that one. It's quite a nice open texture. That was actually designed by my wife for a particular purpose. It was to get an open texture because it's quite easy to see that, and it's also quite easy to stop seeing it. And what I'm interested in is seeing, well, what is happening here? What changes when we go from just seeing the random set of blotches to seeing the giraffe? What is it that actually changes here? I'm going to give another example here, because this is one that you can't switch on and switch off. It's a bit more dramatic. It's a very famous one, which many of you will have seen. This is a very interesting one. Gosh, it's lucky, isn't it? I didn't realise that before. It's got really scratched up. People usually have this. First of all, what happens in a room like this is there'll be some people who see it immediately, and as I'm talking, they wonder what on earth I'm going on about. There's a lot of people who don't see it at all. And I'm not sure whether they've seen it or they haven't, because they don't know what's going on, and they don't know what I'm talking about either, but for the opposite reason. In between, there are a number of people who, whilst I'm talking, suddenly see it. And you hear sort of random gasps going up and so on. For those who can't see it, we've probably quite a few at the moment, what again you've got is a random set of black and white blotches, and you're having a visual experience. But you may not be seeing something, because there is there a very striking head of a man who is looking at you. And the story of this is that it's actually an aerial photograph, and the man who did it was a professional aerial photographer. And one day he was in his dark room and he photographed this, and as he did so, you know how as a photograph develops, it comes up slowly. And this image appeared, and he saw the head of Christ looking at him, and he was immediately converted to Christianity. This tells you a lot about the dynamics of conversion. It is, in fact, here, and for some people, they won't be able to see it. And when we normally spend a lot of time with this, but we haven't got time tonight, and so to cheat, I'm sorry to spoil it for you. There we have it. Can you all see down there? I can't quite get it. There, so yes. Now, the thing is, you see, the important point is, what's the difference between before you see it and after you see it? Because when you see it, what is actually new, whether it's the head of a man or whether it's the giraffe? What is new when you see the figure? It's quite clear when you see this that there's been no change whatsoever among these shapes. There's no extra shapes, or it wasn't that somehow or other you didn't notice some of the shapes, and now you do. They're actually the very same shapes that you saw in the beginning. But now you see something more, and when you see it so clearly, it is quite clear to you that there it is on the wall. It's there. But it isn't. There is no head of a man on that wall at all. But you and I are seeing it there, and once we can see it, we can't stop seeing this one, can we? You can't turn it off once you can see it, whereas with the giraffe you can go from one to the other, which is quite nice. But this one you can't. And you say, of course it's there on the wall, I can see it there on the wall. But if it's there on the wall, why was it that you weren't seeing it before? Was it because there was something wrong with your eyes? No, nothing at all wrong with your eyes. In fact, whether you see it or you don't, you are having the same visual experience. The visual experience or the sense impression is the same whether you see it or you don't. Put it another way, the pattern of retinal stimulation from the light coming in is the same whether you see the head of a man or you don't see the head of a man. We could also call this language of classical philosophy, the sense impression. So you are having a visual experience, but you are not having a cognitive perception until you actually see it. And what we mean, oh, my lighting's gone down tonight. What we mean by cognitive perception is what we ordinarily mean by seeing. When you see the head of the man or the giraffe, it is more than a visual experience. It is more than a sensory experience. There is an extra factor present, which is a non-sensory factor. And that actually is what you see, the head of a man, the head of a giraffe. It looks for all the world as if, once you can see it, it looks for all the world as if it was given to you directly by observation in sense experience. It's just a question of looking with your eyes and then you see it. But by making this disruption, where first we didn't and then we did, we see that that can't be the true story. As well as the sensory component, our eyes, after all, must be open if there's going to be any seeing at all, as well as that sensory component, for us to see, in the sense in which we usually mean the term where we recognise things, there must be another factor which isn't a sensory factor. And it doesn't matter how long you stare at something, the sensory alone will never give you it. There is, in fact, a transformation in which you go from the purely visual experience to the cognitive perception. And what that means is that when your seeing is a knowing, your seeing is a recognizing. You see what it is. There's a recognition in there. Now, the extra factor here, which does this, means that it's become organised in a different kind of way. Just for a moment, I'll go back to the giraffe, because the nice thing about that is that you can with that see it and then not see it. And you can practice this for yourself right now. You see it and then not see it. Let go. You see it and then not see it. And when you do that, you begin to become aware that when you do, you actually experience the seeing, as it were. You actually begin to experience what you see almost within yourself, because you realise that there's no external change whatsoever. And that's one of the advantages of using this particular figure. Is that all right? Have enough time for that? Another way of getting at it is this way. Here we've got one very nice, a cube, which is a reversing cube. This is not a disruption, this is an ambiguous figure. I'll give up on that. You can see this cube so that this is the front face, and it's sort of facing down that way. But you can also see it so this is the front face, and it's facing up that way. You can turn that cube inside out. Most people see it one way or the other and have difficulty going to the second way. But if you can do that, and then you let go, it flips back again. And you can do it, and you can switch it. It's called Scalp Switching. And you can switch from one to the other. And you can see for yourself as plain as daylight that although you see a different cube in each case there, in some sense, sensorially, it's the very same one. But you are seeing it differently. Here's the very famous duck rabbit. That's the common one, that's my version. There we have, you can look at it one way or the other. Look at it that way, it's a duck. That way it's a rabbit, a rather cheeky rabbit, with its ears back and so on and that. And this way it's a duck. That's not such a good rabbit, it didn't come out too well. It looks a bit floppy now, it's on its last legs, that one. But anyway. And again, you can go from the one to the other. You can switch from the duck to the rabbit. There is no, when you go from the one to the other, there is no new visual experience, purely visual experience. The line is exactly the same in both cases. It's not that half this figure is a duck and half is a rabbit. The very same one is a duck and the very same one is a rabbit. And you are doing the switching because you are seeing it. Now, think of seeing actively as a form of doing, like driving or walking. Because we don't think of it that way. We think of seeing as simply a matter of visual experience. I open my eyes and the world floods in and there it all is. We think seeing is just a sense experience. This shows us that it isn't. There's an active component in seeing, and we bring that to it from a different part of ourselves, as it were. And literally, we see it. Let's take that in an active sense as a doing sense. Let me put it this way. We see the duck when we see duckly. We see the giraffe when we see giraffely. What we're doing in our seeing constitutes the giraffe, constitutes the duck. But we think of it as an object sitting there from which we receive an impression. Well, it simply isn't like that. And all our ordinary knowledge is like that, because the extra factor here is that there is an organizing idea. So you can call that a concept, you can call it an idea, but I've got to hurry here. You have to spend a long time on this, because in England we have very, very awkward idea of what an idea is. And the first problem we have to do, if we're really going to understand this, is to overcome the English idea of what an idea is. And that's the great, we haven't got time tonight. So what I can do, give you this statement which I'm working from. This is Franz Brentano, who was the philosopher who taught Edmund Husserl, who founded the School of Phenomenology, and also who taught Frege, who founded the School of Analytical Philosophy. So that's the teacher of the founders of the two major schools of European philosophy in the 20th century. And he said, by idea, I mean the act of conceiving, not that which is conceived. So he means here the act of conceiving, the seeing it, the conceiving it, not. And in England we don't. We say, oh, well, there is something there, the jug, and I formed the idea of the jug, is what David Hume, Bishop Bruce, called a faded copy in my mind. This is not what he means here. He means that the idea is the act of conceiving, not that which is conceived. You've got to get into the act. And the whole art of this is to learn how to shift attention. Because our attention is always on what is seen. Because when you see something, you see something. So I see the jug, my attention's on the jug. You can't put your attention into the seeing without seeing something, but you can practice trying to shift your attention from what is seen into the act of seeing it. So instead of your attention being on the jug, it's in the seeing of the jug. And it is possible, by means of exercises and so on and that, to actually practice this kind of thing, and instead of having to rely on these kind of figures, to begin to catch it for yourself. And that's very interesting, because when we do that, then we discover that this, of course, is what is happening to us throughout all the time. Because in where we are now, in the world, in this room, everywhere we look, there's not just a sense experience, there is an active idea. There is the concept which is organizing the experience, so it goes from visual experience into cognitive perception. If I am in a society where they do not have, or have not had, the concept pen, let us say, and I hold this up, let's do another one, another one. If I am in a society where they have not got the concept chair, then in fact they cannot see what you are seeing now. Every one of us, the moment we look at this, we see a chair, providing we're not dysfunctional. We see a chair directly. And we think it's entirely a sense experience, because what we've got is the coalescence of a visual appearance with an active concept, but we're not aware of the active concept. And we see, as in the case of the figure, we see things as being where the sensory stimulus originates. So if I take this there, let's check. Oh, it's not upside down. Where is it? Where's that? If I take this picture there, we... now you see it, now you don't. Yes, let's try it this way. Thank you. We, no, that's better. We see it there, and we can't not see it there, but it isn't there, it's actually in our seeing. But where we see it is where the sense experience originates from. That's the terminus, as it were, and that's where our seeing stops. So that's where we see it. So with everything, it's like that. And if we see the chair, then there's a coalescence of the concept and the sense experience as one. And so we just see a chair. But if we're in a society where people did not have the concept chair, did not have the idea chair, they could not see what you and I are seeing now. Of course they would see something, and they would see something which in a way resembles this object. But if I just picked that up like that, you would immediately, without drawing your attention to it, you would immediately see a chair. They will not see a chair. They cannot see a chair. Whatever they see, they'll perhaps try to make something out of it in terms of their own culture, but they cannot see a chair because they do not have the concept. And in our everyday life, as it were, these concepts, these organising ideas are active all the time with our sense experience to bring us what we experience as direct knowledge of the world and imagine as a purely sensory experience. So we miss the dimension of mind. We actually live in a dimension of mind, which in a way, it's like we live in an ocean of mind. It's not that mind is within us. We should think of ourselves more as being within mind, because we are actually formed within mind. And we live in this ocean or dimension of mind, and it's completely invisible to us. So we have a kind of flatland approach to things because we're missing a whole dimension which is part of our immediate experience. Sometimes you get breakdowns. There are anesthetics where they interfere with these things, and as you're gradually going down, you can actually watch this happening as you're coming out again. You can actually follow this kind of thing quite carefully for a few seconds anyway, and so on. But there are various other ways of getting at this, but I think I've said enough about that for the moment, because what I want to talk about is the way in which, obviously, this must be understood, because if it is not, then we make the mistake of thinking that knowledge is empirical, and hence scientific knowledge is empirical. So what I want to talk about now is a few examples from science. And I'll only take some simple ones. Because in a way, scientific discovery is actually rather like this. The act of discovery is also a case where the discovery is actually the coming of the idea, the concept, because before something has been discovered, the idea isn't there. And very often with quite simple observational discoveries, it looks as if things were just observed directly through the senses. Consider, for example, Galileo. Everybody knows that Galileo made discoveries with the telescope. He discovered that there are mountains and there are craters on the moon. He discovered that there are 4 moons going around Jupiter, and he did this with his telescope. And other people wouldn't believe him. And they think what happens is that Galileo made a telescope and he looked to it. And he said, good heavens, look, mountains and craters on the moon. Good Lord, 4 moons going around Jupiter. And other people, when he said, have a look, they said, no, impossible, can't be done. And they wouldn't look. In fact, lots of people looked, but they couldn't see them. And they said, we can't see what you're banging on about, Galileo. Now the reason is because we've got to take into account here there are 2 aspects to this. There's the purely visual experience, and then there's the transformation of that into the cognitive perception of moons around Jupiter, or mountains and craters. And Galileo in his writing is quite careful. In his book Sidereus Nuncius, he actually is quite careful about this in the way he writes about it, and makes it quite plain, and I've got this somewhere, all I have to do is to find it. There we are. He makes it quite plain that it took him some time. And here's some pictures here. I haven't got time to read his quotes tonight, but he said, when I look at the moon, he said, I saw a largest number of spots, more spots than you see with the naked eye. There were the usual large spots, and then lots of very much smaller spots, which have never been seen before by anyone else but me. It's very typical of Galileo, is that? And he observed these these previously unobserved spots very carefully, and this is the kind of the raw visual experience is more spots. And he gradually finds that with them, he said in some of these spots, it's dark and there's a bright ring like that. And eventually this bright ring spreads to fill the whole thing. And he says, why? He says, would that not be what it's like on the Earth? If you have mountains and a valley, and the sun rises in the morning over there, will it not in fact light that rim? So if it was seen from above, you would see a bright rim there and the rest would be dark. Can you all see over there? And that as the sun rose up, that this would fill up and become filled with light. He said that's what we see on the Earth. Well, he said there must be craters on the moon. He called them valleys on the moon. Inside the dark parts of the moon, he found tiny spots of light, which eventually again filled out and became full. And he said, why, would that not be that these are tall mountains and the sun is such an angle that it's just catching their peaks as we have on Earth? And he writes about all of this. And then you realize that's when he comes to see these things. And then he says, I can see mountains and valleys on the moon. And he shows it to someone else and they say, get away. Right? But then people say, oh, well, it's wrong. Because people will think, you see, that the observation is purely empirical. It's all a matter of sense experience. But there is the real thing in the discovery is the transformative step, which is the coming of the idea. And that transforms the experience from a visual sensory experience into cognitive perception. And that's what science is concerned with, not the former. When it comes to the moons around Jupiter, that's very extraordinary. This is a sort of picture of them, I think. There's back there, there's three little blobs there. You won't see those much, there you are. And this one, for some extraordinary reason, has got a bit of green on it. I'm not going to do it there. I'll leave that for later. That's a very good example of conceptual cognitive confusion. I haven't got the idea at all, have I? Oh, dear me. Right. 7th of January 1610, he observed next to Jupiter 3 spots of light. And he says in his book, I thought nothing of it. I simply thought there were 3 stars close to Jupiter. They could, of course, have been at any distance, but they just happened to be lined up close to Jupiter. He said, I did notice they were in a line, but I thought nothing of it. The next day he observed again, and he found that instead of 2 on one side, one on the other, he got 3 on one side. He thought, well, that's very odd. And he thought, what can that be? And he thought, well, Jupiter must be moving in the other direction, to the direction which the astronomers at the moment say it's moving. So he thought the astronomers were wrong, and Jupiter had moved that way. The next day was cloudy. And he goes on, and eventually there's 2, and then a 4th one pops up. After quite a long time, it gradually dawns on him that what he's seeing is planets, because planet just meant a wandering body, going around Jupiter. 4 moons round Jupiter. But it took him a long time, and his book is full of those diagrams. It goes on for, quite boring really, because it goes on for days and days and days, about a month or more of these diagrams. And then there's the transformation to the cognitive perception, and then he sees moons round Jupiter. And people say Galileo looked through his telescope and saw moons through Jupiter. You see, again, we miss the dimension of mind, which is active in perception. So we don't understand the basis of knowledge. The final example here, which I think is very instructive of this kind of thing, is the discovery of the planet Uranus by Herschel. I mean, everybody knows that Herschel discovered this particular planet. And he did this in 1781, and he built a much bigger telescope than other people. He built it himself. And in the position which we now know as having been at the time occupied by Uranus, he saw something that had a disc shape. So he thought, well, that can't be a star. Now we also know from that record that the 20 years before people had seen something there, that they thought it was a star because they hadn't a big enough telescope. He had a bigger telescope, so it was disc-shaped. So he knew that it couldn't be a star. He didn't know what it was. It might be a nebula. They were very keen on nebulas at that time. It started Messier's list and so on, concepts. And that is why I say it is not true that scientific knowledge is not empirical in the way that we think it is. Now this is very interesting, because if people believe that science is certain because you can always decide scientific propositions by going and observing things, that clearly is not true. And it's very important for us to understand this about science, that it is. Now, just to the next bit, and I may just have time to say a word about Darwin. I want to say a word about, I do want to say a word about this next bit, if you can bear with me, which is on Copernicus, because here, so far what I've talked about is very simple observational discoveries. Now, science, of course, is not fundamentally concerned with simple observational discoveries. What really matters in science, what really counts and affects us, is the development of much more all-embracing organising ideas, which are called scientific theories. And the one I want to look at here is Copernicus' discovery of the heliocentric universe, the sun-centred universe, and the fact that the Earth moves around the sun, and not the sun and everything else around the Earth as had previously been thought. You might wonder how he came to do this, and most people suppose, well, it was because he made new observations. Not a bit of it. He didn't make a single new observation. In fact, in his book, which was published in 1543, he used most of the same observations that had been in Ptolemy's book from AD 150, plus a few added by the Arabs in between. So there were no new observations in his book which led him to this conclusion. Furthermore, the actual accepted theory of the time worked really quite well. It's one of the, Paul Feyerabend said, it's one of the best theories there's ever been. We tend today to laugh about Ptolemy's theory and its epicycles, but actually, the truth is it worked extremely well. There were problems, but there's problems with everything. So the question would be, why on earth, how on earth did he come to make this change? Because you might say, well, having made this, it must have led to better results than the previous theory. Well, it didn't. Actually, to begin with, the results were no better than, and in some cases worse than, the theory that had been around for 1,800 years. 1,500 years. 30, oh, I don't know. A long time. And there were other problems too, which I'll come to in a moment. Well, he tells us, actually, in the preface to his work, he actually tells us what he's doing. I can switch this off now. He tells us what he's doing. In a few quotations will soon, I think, help us here. He says, first of all, he says, if you look at the way it's done at the present time, the astronomers and mathematicians have not been able to discern or deduce the principal thing, namely the shape of the universe and the unchangeable symmetry of its parts. With them, it is as though an artist were to gather the hands, feet, head and other members for his images from different models, each part excellently drawn, but not related to a single body. And since they in no way match each other, the result would be monster rather than man. That's how he describes the the geocentric system as it had actually developed. Now, in fact, that's a very interesting statement, because anyone who's familiar with Alberti's book will recognise that, because that's almost a straight quote from Alberti's book. I forgot the title, but it's roughly How to Be a Successful Renaissance Painter. And when he wrote that, then it's quite clear that he would expect people at the time to recognise what he was saying. He then goes on to say, so what he's saying is it's like bits taken from different models.